So, hello everyone, my name is Zhu Yuanwang from Chinese University of Hong Kong. The paper I will present is joint work with Professor Lin Gao from HIT and Professor Jianwei Huang from COHK. So let me start with the background. In practice, as we all know, the mobile network operator profit from wireless data services through carefully design and optimizing their mobile data plan. Actually, it's usually a three-part tariff, consists of a data cap and a monthly subscription fee and a per unit fee for exceeding the data cap. And to increase their profit, some operators usually proceed price discrimination and offering their subscribers with some time flexibility. So, first of all, as for price discrimination, most operators will offer multiple data caps with different subscription fees for users to choose from. And this is actually the so-called second-degree price discrimination in economics. As for time flexibility, let's first talk about the mobile data plan without time flexibility. So in the traditional data plan, let's suppose we have a 3 GB data cap as shown in the top figure, and 2 GB data consumption in January. Then we know the 1 GB data left in January will expire when we move on to February. However, under the rollover data plan offered by AT&T, the 1 GB data left in January can roll over to the next month and actually is consumed after the 3 GB data cap in February is totally used up. As for the rollover data plan offered by China Mobile, similarly, the 1 GB data left in January can roll over to the next month, but the difference is the consumption priority. And shown in the bottom figure, the rollover data is first consumed, which is prior to the monthly data cap. So in our previous work, we focus on the case without price discrimination. In other words, we only consider a single cap, and we look at this problem in both monopoly and competitive market. In this work, we will focus on the case with price discrimination, with multiple data caps. So, through this work, we try to answer the following two key questions. The first, how should the operator optimize the multi-cap data plan? And what's the impact of time flexibility under the multi-cap scheme? First of all, let me start to introduce our system model. We characterize various mobile data plans through 4 parameters. Here, the capital Q is the monthly data cap, capital Pi and lowercase pi as a subscription fee and the per unit fee for exceeding the data cap. Kappa is chosen from 0, 1, and 2. It represents the data mechanism. Specifically, kappa equals to 0, it represents the traditional one without any flexibility. And 1 and 2 represents the 2 rollover mechanism offered by AT&T and China Mobile. So in the rollover data plan, we would like to use top in the table to denote the rollover data from the previous month. And we will use Q kappa E top to denote the effective cap, within which there is no overage fee incurred. So obviously, under the traditional data plan, we will always have 0 rollover data, and the effective data cap as shown in this table is the same as the monthly quota Q. As for the 2 rollover mechanism, the effective cap actually is the summation between the monthly cap and the rollover data. But again, the difference is the consumption priority between the rollover data from the previous month and the current monthly data cap. So as for mobile users, we characterize each user by 3 parameters. D is the data demand, the monthly data demand, which is stochastic with a distribution FOD, and is also discrete, measured in minimum data unit, 1 kilobyte or 1 megabyte. Theta is the user's data valuation for consuming unit of data. Moreover, we also want to capture users' behavior change after exceeding the effective cap, since it incurs additional payment for this user. Mathematically speaking, we model this by cutting beta fraction of data demand above the effective data cap. And we refer to this parameter as the user's network substitutability. So under this setting, the user's payoff with demand D and the rollover data total is characterized by this equation. The first term is the utility of consuming data. Specifically, it's the multiplication between users' data valuation and the actual data demand, considering cutting beta fraction demand exceeding the data cap. And the second term is the possible overage fee. And the last term is the monthly subscription fee for these users. So here the two parameters D and tau are two random variables with changes in each month. So we take the expectation to derive the user's expected payoff and shown in this equation. Similarly, the first part is the expected utility and the second part is the expected overage fee. So here the red term, A kappa Q, is the user's average overage data consumption under the data mechanism kappa. Intuitively, if a data mechanism offers you a better time flexibility, then it will incur less overage data consumption, hence a smaller value for A kappa Q. Our analysis shows that the following inequalities always hold, which implies that among the three data mechanisms, the rollover data mechanism offered by China Mobile is the most time flexible, and of course the traditional one is the worst case. So as for the operators, we consider an asymmetric information scenario. Specifically, each user has multidimensional private information, which is their data valuation and the network substitutability. The operator cannot know each user's private preferences exactly, but we suppose the operator can estimate the statistic information from the whole user market. So the operator's problem can be formulated in 3 steps. In step 1, the operator will first collect some information to estimate users' private preferences. In step 2, the operator will choose a data mechanism to implement and then optimize the multi-camp contract under the chosen data mechanism and considering users' preferences. So mathematically speaking, we consider key different data valuation, theta k, and M network substitutability types, beta M. And the operator needs to design a feasible contract which contains key M contract item, one for each type of users. Each contract item is a combination between the monthly data cap and the corresponding subscription fee. So here we see that the contract is feasible if and only if each type of user will select the contract item intended for this type of users. To make the contract feasible, we need to guarantee two conditions. First, we should make sure that each type of user can achieve a non-negative payoff by choosing the contract item designed for himself, which corresponds to the individual rationality constraint. And we also need to guarantee that each type of user can achieve the maximal utility by choosing the contract designed for him, which corresponds to the incentive compatibility. So the operator's revenue under a feasible contract is actually the aggregate payment received from different types of users, including the subscription fee and the possible overage fee. As for operator's cost, we consider two kinds of cost: the operational cost proportional to the total data demand, and the capacity cost increasing in the data camp queue. Eventually, the operator needs to maximize its revenue maximize its profit, considering all of the individual rationality and incentive compatibility constraints. So the main difficulty of this problem is, of course, the two-dimensional private information. So we need to answer the following key questions. Under the two-dimensional user type, theta and beta, which type of user should be allocated a larger data cap? So to answer this question, let me first introduce the indifference curve. So in economics, the indifference curve will connect those goods bundlings that can achieve the same user payoff. So as shown in this figure, the horizontal and the vertical axis corresponds to the data cap the monthly data camp and the monthly subscription fee. The two blue curves in this figure are two indifference curves with payoff equals to 1 and equals to 3. So from this figure, we find that when the indifference curve is shifted upwards, the corresponding payoff is decreasing due to the increasing monthly subscription fee. Moreover, actually the slope of the indifference curve is referred to the marginal rate of substitution, denoted by sigma in this work. And actually it's a rate that the user is willing to give up one good in exchange for another, while maintaining the same user payoff. Actually, it can indicate the user's willingness to pay for the particular data camp. So next, for notation simplicity, let me define lambda I to denote the two-dimensional user type, and use phi I to denote the contract item for lambda I user. Our analysis shows that for any feasible contract, if lambda I user has a larger willingness to pay compared with lambda J user, then the feasible contract will allocate no smaller data camp for lambda I user. We can also illustrate these insights through this figure. Similarly, the two axes corresponds to the monthly data camp and the monthly subscription fee. Let's suppose the red circle is the contract item designed for lambda J user, and the corresponding red curve is the indifference curve for this type of user. The blue curve in this figure is another indifference curve, but it's an indifference curve of lambda J user. So now we want to claim that the satisfying under the individual rationality and incentive compatibility condition, the feasible contract item for lambda I user must appear in the blue region. We can easily prove this by contradiction. Let's suppose it's not in the blue region, but the square one. So if it's at the square one, we will notice that the blue curve has to be shifted upwards to touch square one. Actually, in this process, the corresponding payoff is decreasing due to the increasing monthly subscription fee. So this similar argument is also applicable to square 2, 3, 4, 5, and eventually we will find the corresponding data camp in the blue region is no smaller than the data camp and the red circle. So with the help of this insight, we can solve the operator's multidimensional contract design in four steps. Specifically, in step 1, we will reward the users according to their willingness to pay. I will not go into details, but show you some numerical results. So actually in this work, we conducted a market survey to estimate users' preferences and cluster the empirical data into several categories. Eventually, in this simulation, we consider 4 types of data evaluation and 4 types of network substitutability. Specifically, the distribution information is illustrated in the left figure. In the red figure, the two axes corresponds to the user's two-dimensional preferences, theta and beta. And the arrow in this figure points to the direction along which users' willingness to pay is increasing. And we also use the same marker to represent that in the optimal contract, the operator tends to offer the same contract item for this type of users. So from this figure, actually we are offering 7 different contract items for a total of 16 types of users. So we also look at the impact of price discrimination and time flexibility. In the two figures, the horizontal axis represents the operator's capacity cost, and the vertical axis in the left figure is the operator's profit, and the vertical axis in the right figure is the user's payoff. The black curve without marker in this figure is our benchmark without price discrimination and without time flexibility. So by comparing the two black curves, we will find that the price discrimination can significantly increase the operator's profit but decrease users' payoff. by comparing the three curves with markers, we will notice that the time flexibility offered by rollover mechanism can actually increase both operators' profit and the user's payoff. So here's a conclusion. In this work, we studied the operator's optimal multi-camp design, considering users' two-dimensional private information on the different rollover mechanism. And we also look at the impact of time flexibility and price discrimination. As for the future work, one of the most straightforward direction is to look at the market computation under the multi-camp scheme. And there's also some other topics. Actually, the rollover data plan offers users consumption flexibility from the time dimension. There are still some innovative data plan. For example, the family data plan allows several family members to share the same data camp, offers you some flexibility from user's dimension, and the global data plan allowing you to consume the same data camp in several different countries, offers some location flexibility. So actually, as we will see in the future, I think we will find more and more innovative data plan. So in one word, there are still many interesting and critical topics in this area. So this concludes my talk. Thanks.